Welcome to the evening session of the coding train. Here we go. I feel emboldened by the fact that it's like spring break at NYU. I feel like there's nobody on the floor. I could be loud and a little crazy. It's the evening. I've got something to show you guys. First of all, can you hear me? Does the sound okay? I got something to show you guys. This is very exciting. This is what is known as, let me pause this. This is very important. This is a picture. This is not a 3D model. This is not CGI. This is not some computer-generated teapot. No. This is a pitcher of water. What I can do with this pitcher of water is after I drink some of this water, bring my mic up a little bit, okay, I can pour water from this pitcher into this mug and drink some more. So guess what? I have a good feeling about this evening. I have come prepared with enough water to last me for a very long time because as we know here on the coding train, it is very important to stay hydrated. You gotta stay hydrated. All right. Now, I'm told maybe I have done some things. I have also done some things with my sound system here. I have a whole new setup. It's ridiculous. The amount of places that this sound from this tablet goes from here into an audio interface, out through that to a USB connection to this laptop, and then out through this Thunderbolt port into a Blackmagic box, into another machine to be captured, which is all completely crazy. But it works, I think. Oh.
As always, I always.
Oh, it started over. That's fine. I've got this. Now, you might be wondering what is going to happen on tonight's coding train. I wanted to load a whole lot of new sound effects because by the time I got this working, though, I was already about a half an hour later than I said it was going to be. The train. Oh, everything's on loop. Oh, turn loop off. How do I do that? No, stop, loop. Ah, got it. Nothing will loop anymore. Now, it's important in the evening time as you get settled in for a quiet rest in your chair in front of your thing that you're watching YouTube on. A nice sip of some warm tea, ginger perhaps, a little lemon. No lemon for me though, it's gonna irritate my throat. But ginger, it's wonderful. I'm going to read you all a coding train story. Our story begins many, many years ago in the 1940s at the Rand Corporation, where predictability fails, but a sufficiently large sequence of random digits, like the present one, can confidently calculate outcomes that depend on probability assumptions. If you remember last time on the coding train, 5,549, 70,101, 92,945. Oh, you can't hear that, can you? That's so good. And then, 27,026. This is not working. It's getting better though. I really feel like I'm starting to, by the way, when I get the messages start coding or leave, that only encourages me to take longer. I essentially have this, yeah. Oh, okay, here we go. I must continue. Whoa, I'm playing this 3 times now. 59,762. 74,343. 51,864. 22,327. 55,480. 95,907. 77,900. 189. 88,732. 93,567. 75,074. Are you all remembering to stay hydrated? Stay hydrated. 32,414. 81,044. Is it looping? No, it's just really long. 77,751. 86,018. 85,835. Okay, now, apparently there's a lot of people in Europe and probably other countries, but I'm thinking of Europe right now because it's mostly around midnight, somewhere between midnight and 1 probably. Everybody's lying in bed. But that's what I do here on the coding train. I like to soothe souls, bring joyous code algorithms into the world in a quiet and relaxed way. No, I am not frenetic and crazed and manic at all. Nobody writes YouTube comments like, I'll have what he's having, blah, blah, blah. That does not happen. I just here, relaxed, drinking my tea and my water to stay hydrated. Ready to go. Now, I probably gave it enough time. I think everybody who wanted to joined, and everybody who wanted to leave has left, which is probably at least 75% of whoever started joining. And I am now going to start working on stuff that I did earlier. Okay, so, let's see. Now, you might recall a friend of mine. This is my dancing tentacle friend. Let's go get the dancing tentacle friend. I think it was this one. Oh, it's like, he's lullabying tonight. We've got to work this. We've got to fix this. This is no good. This is no good at all. I cannot tolerate this. Oh, stop. I really can't imagine that you guys can handle me playing the lullaby music anymore. Okay, let's see. Where's our friend here? Where's our friend? Why is our friend the tentacle not dancing the way that I feel would be appropriate? Here we go. Come on, ready? As always, I always forget the this dot. I'm going to do this dot. I'm going to do this dot. Oh, that's way too much. I'm going to do this dot. I'm trying to this dot. This is not really working. Okay, hold on. This dot. Did you think I was here to do coding? No, that was this morning. I'm just messing around, wasting time. I was going to do like the, what are those things that people do now? The don't say aw challenge. You just look at cute pictures of animals and you try not to say aw. That's what I was going to do. As always, I always forget the this dot. I'm going to do this dot. Over here, friend. Here we go. This dot. I'm going to do this dot. I'm going to do this dot. This dot song. This dot. Never forget the this dot. Okay, I think this was me warming up. So, you might be wondering, what is it that this is? So this is an example of forward kinematics. It's an example that I built this morning in one coding challenge to make a tentacle. And I want to do a few variations on the forward kinematics. Let me start over. There's no, I don't know why I'm starting over. This is my friend, the tentacle. It is an example of forward kinematics using Perlin noise. I see a message in the chat saying I've got a tentacle on my head. And guess what? You know, when I was in olden times, when I was a young person, I wrote a song once. And that song is called, I can't believe I'm going to do this now. I've got rice on my face. And it went something like this. I've got rice on my face, uh-oh. Oh no! Whoa, wait, I've purchased this software. Look at this, it just, can you hear that horrible static? Okay, stop. So first of all, help, 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 unplug, unplug, unplug. There we go, okay. So this is software called Loopback that I'm using that I have purchased. I was about to, it knew, it was like, please, whatever you do, don't sing the Rice song. So like the gods of the internet and static were like, please, whatever you do, don't sing the Rice song. Like immediately, okay, I gotta get into my email over here and get my Loopback license. On this other computer, your Loopback license key. Oh my goodness, this is like, I might as well do another reading of the, Oh wait, I'm gonna type in my license code and everyone's gonna have my license code to this software. I guess I need to unplug, this is dangerous. I'm gonna go into the void. I'm in the void. So I can still see my computer, but you cannot because I unplugged it. So, okay, hold on. What am I at, 11 minutes? I've only been doing this for 11 minutes, that's nothing. Not only am, oops, okay, hold on. I'm typing in my license key. I wish I could have someone read it to me. It's crazy that it suddenly just made it fill with static. Oh my God, there's no way I've typed this in correctly. It's sad that you can't see what I'm doing. This is riveting. I'm sure this is like, I'm gonna win, what's the like, is there some kind of like internet award I can win, like equivalent of an Emmy? Live stream, typing in license codes. Okay, unlock. Oh, that worked. Somehow I got it right. Fully unlocked. Thank you. Thank you very much. I'm going to now bring it back. Come back. All right. Oh, there's my tentacle friend. Okay, now I'm going to plug this back in. What's the chance that it's still going to be working? And hopefully there's not going to be any static. I don't hear any static. What's the chance this works?
As always, I always forget this dot, this dot, this dot, this dot.
Okay, hold on. Wow. Oh, best laid intentions. Let's go here. Okay, let's see. Let me just start over here and add a new device and get it from this thing, and then monitor audio. There's static now. Why is there static? There wasn't before. Okay, everybody. Okay. Manual. Let's get it into stereo. I gotta do this ridiculous thing that I'm doing. Don't even ask why I'm doing this. Oh, monitor audio. Okay. I think I'm good now.
As always, I always forget the this dot, this dot, this dot, this dot.
Are you tired of this song yet?
This dot, I gonna do this dot, this dot, this dot. I gonna do
Okay.
this dot, this dot. I gonna do dot.
I will have to sing to you my composition. Rice on my face, peas on my knees, foil on my toes. Cones on, it's not rice on my face. That's not the song. It's cones on my head. I can't believe I forgot this. Oh my goodness. I will now perform for you because I have so much water. I feel so powerful. I could do anything. Maybe I could do the neural network stuff. I'm so terrified. I'm gonna need a lot of water for that. I've got cones on my head, cones on my head. Don't ask me why. I've got cones on my head, cones on my head. Don't ask me why. Got rice on my face, peas on my knees, foil on my toes, cones on my... There was a thing. It like had a whole bunch of different verses. I don't have it now. And there were props. I was actually wearing cones or peas, foil on the toes. It was very strange. It was a dark time. Maybe this didn't happen. Maybe it was all a dream. I think it was all a dream. Okay, so people in the chat are asking, could you please explain what object literals are? Oh my God. That's so kind of you guys to stay here when I'm clearly a completely insane person who has all the knowledge about programming it's melted because it's like practically 80 degrees in this room. I am sending a note to facilities management something, and I'm going to get some air into this room. Because right now, I'm all set with the water. I figured that out. It's called a pitcher. Okay. Let me make a few other announcements. Number one is I've now become a completely ridiculous used car salesperson. I've got Coding Train t-shirts by popular demand. I don't know if I made up that popular demand. I demanded it in a popular way. If you would like to get any of those, you can go to codingtrain.storeenvy.com. There's the URL for you. And then you can also get a mug by clicking on mug here. I should really get this mug. This mug looks much nicer to me than this mug. Anyway, but that's the mug I have. Look at this. Coding Train, brought to you by the Coding Train. It's deliciously refreshing because it's just water. Okay, now, another thing that I want to mention is, Google Summer of Code. So I'll give this a little plug here. Summer of Code Google. Google Summer of Code is, and this is actually not the site that I want to look at, although this is perfectly a reasonable place to go. I want to go to the program site. So Google Summer of Code is a program if you are a student, even if you're a graduating student, as long as you check the website for eligibility, you are eligible to apply to get paid to work on an open source project over the summer. And if I click here on organizations, you will see there are lots and lots of organizations. And so if you're interested and you have, I would say one of the organizations you can apply to is the Processing Foundation. And if you're interested in applying to the Processing Foundation, you feel like, well, maybe I'm a beginner or I've never really done open source before, or people who do open source, they don't look like me, I must not be invited. This is not true. Please come and get involved. Apply, send me a tweet at Schiffman. But a place where you can post a question that I check relatively often is the Processing Forum, which is forum.processing.org. And if I go down here, you can see the category Google Summer of Code. There also is a program that we're participating in called Rails Girls Summer of Code, which is similar. I'm just not mentioning that because the application period has ended. So you can no longer apply to that, although it looks like there's a terrific set of applications, so I'm very excited about that. So, oh my goodness, 19 discussions. So I clearly have not been responding to these, and you can see here that you can post your idea. And also, you know what you could do? Here's the thing you could do. You don't even want to apply to Google Summer of Code. You're not a student, but you could come here and participate in the discussion and post your thoughts about if you're a member of the community, you're using processing, you're using P5, you should participate in this conversation to figure out what are good projects, exciting and interesting projects to work on over the summer. Okay, now, I wanted to mention that. And then now I want to go back and we don't need this. I want to go back to processing and my friend here, Tenticular. I don't know, I need a better name. I don't know what the name for this friend of mine is. But anyway, can I please get a piece of merchandise that doesn't look like I'm on a My Little Pony convention? Well, guess what? Are there My Little Pony conventions? Is that a thing I could go to? That would be really exciting, because my favorite My Little Pony is a Rainbow Dash, I think. I think that's my favorite one. That's at least the one that I know. Is that too obvious? That was too obvious. I should pick like a lesser known My Little Pony. I have all this weird knowledge in my head. I have a lot of knowledge about My Little Pony, and I also have a lot of Pokemon knowledge, which I don't know if I want to start going down that road. It's a little bit weird. There's I was gonna try to like name an obscure Pokemon and sound really cool, but I couldn't. Okay, now, okay, let's keep going here. So what do I want to do? It's already 6:30. I have a little bit of time to be here. There will be some content. What I would like to do is expand on my kinematics videos, and in particular, I'm going to go to my inverse kinematics one. This is another example that I built this morning. And this is an example where using inverse kinematics to follow the mouse. And I've got this kind of eel-like creature following the mouse. And there's a couple things that I mentioned. Number one is, one thing I want to do, I'm going to do two things. I'm going to do two things. Oh, you guys are excited for the content. Uh-oh, is that a weird, maybe I said the wrong thing about My Little Pony. I hang out with a lot of small children who have a lot of My Little Pony toys because I'm a parent of children and they have friends over and things. And so that's where my knowledge comes from, in case you're wondering. Okay, moving along. But not that there's anything wrong with liking My Little Pony anyway. So stop messing around with me in the chat and messing with my head. I can like unicorns. Okay, I didn't even know that was a thing. What people are talking about in the chat now. Because I'm old. I might not look, apparently I don't look old. I think it's the lighting in here. Now I'm feeling a little verklempt. I'm moving on. I gotta move on. Okay, see the problem is when I look at my monitor, I also see the chat. Okay, that sounded even worse. Okay, we're moving on. I'm going to move on. Okay, so I'm going to do two things. One is I want to just turn this into an object to make a bunch of them and have them move around according to some other logic. And then the other thing I want to do is lock the base, which will make it more like what a robotic arm would actually do. So I don't know which one I should do first. I don't know which one I should do first. Things were going so well. I felt like this was one of my better live streams. Not that, I'm self-evaluating a lot. In the sense that I'm completely not doing anything code-wise. I see there's some typing in this Slack channel over here. Okay. All right. So I'm going to, let's build off of this. Okay. So here we go. It is time for a coding challenge. The train's pulling into the station. Let's do save as, what should I call these? Squigglies? Squigglies on the desktop. Okay. So I'm thinking I could do, I wonder if, I'm going to do something kind of crazy. I think this will be interesting. Oh no, but no, that's not going to work. It's fine. Okay, here we go. Noodles. It does kind of look like a noodle. I like that. I like noodles. Okay. Maybe I could get a coding train branded train whistle. Okay, here we go. Hello, welcome. This is another video in my kinematics series, and in this coding challenge I'm going to take an extra step. It's kind of a loud train. It's going away. Okay. Oh my God. I'm going to try, this is what I built. It's an inverse kinematics system that is following the mouse, and each segment of that system gets a little thinner as it goes towards the back of this squiggly snake-like creature. So what I just want to do in this video actually is just take this a step further, and I want to make this a single object so I can have more than one of these on the screen, and then maybe I'll make a little scene of all these squigglies moving around. Okay. or noodles. I don't know. You have a spaghetti simulation, which isn't really what it is. Okay, am I getting hungry? I don't know. Okay, so let's move forward here. So one of the things, the way that I did this previously is everything, the only object was this segment object. The segment object being one, it's a little hard to see because it's all blended together, but one segment of this particular body. You can kind of see close up that there are actually these kind of rigid segments. They're just lines connecting the different parts. So what I want to do is I'm going to rename this tab because I like the word squiggly better. So I'm going to make a squiggly. It's not really that squiggly, but I'm sure you could make it squigglier than I will. And what I want to do is I want to just take all of this stuff that's in the main program and put it in another object. This I think is going to be relatively painless. No squigglies were harmed during the making of this coding challenge. So I know that each squiggly needs to have a tentacle. Then in the constructor, it should do all of this stuff. Right? In the constructor, it should set up all of its segments. Same sort of thing we did before. Then it could have its own, it could have some functions like update. And what it does in update is all of this stuff. And let me though let's just take out the rendering and make that a separate function. It's a little bit redundant then to do that, but it could be useful. And so I'm just moving stuff around. You can kind of, I should probably explain what I'm doing a little bit more. I don't know why I'm not doing that. Usually that's all I ever do. But let's just take a look. Well, all I did was say, okay, there was all this stuff that was in the main program. There was some things that happened in setup. So when I make an object, the stuff that happened in setup in the program should happen in the object's constructor, because the object's constructor is like the object setup. Set up all my segments. Then when the object needs to be updated, it should follow the mouse and go through its iterative linked list style like loop where it goes from segment to segment to segment and have each segment follow its child, update and show it, and move to the next segment. Then I just took the other stuff out to draw it separately in show because that could be useful potentially. I don't have an idea of why it would be useful, but I'm kind of separating that logic. So now I should be able to just say, look at this, there's nothing left in the main program. Squiggly S equals new squiggly, and then this is really just an excuse to say squiggly all the time. S.show, S.update. And now if I run this, same exact program, but this is what I'm excited about. Now what I could do is I could have an array list. Array list, I could have an array, but let's use an array list. Squiggly, squigglies. Squigglies equals do array list with a squiggly in it. Then I'm going to say squigglies.add a new squiggly, and then for every squiggly, S in the array list squigglies, I'm going to show and update them. So this should also now be, come on, run. This should also be exactly the same. So far, all I've done, this is like reorganize my code. And you know what? Sometimes in life, there's nothing more satisfying and relaxing than reorganizing your code. Okay, never mind. But the power here is that I could add some more of them. So what happens now if I add a bunch of other squigglies? There's 3 of them. I still only see 1. Well, the issue is they're all made exactly the same way, and they're all following the mouse in exactly the same way. So even though I made 3 of them, they are all exactly on top of the mouse. So what I want to do, I mean, there's so many things I could do here. But what I think that I want to do is I want to, I'm reading the chat and people are somehow upset about I think there's a lot of cringing going on with talking about the word squiggly too much. Edit this out. Oh, for each. Yes, that's kind of a for each loop. Okay, I am going to change the way they move. So right now, what the squiggly does is it follows the mouse, and they all follow the mouse. But there's no reason why I couldn't have some other x and y that it follows. So let's say that x and y equals, I'm going to set the place that it follows, and maybe I should call this like target x or something, or target y. You know what? I have an idea. P vector position. Because you know what we can do eventually is we can just integrate this with all of my other steering nature of code examples. Position equals new p vector, and let's just put it in the center of the window. And let's say it follows that p vector. And now what I could do is in update, how does that p vector move? Pos.x plus equals some random amount. This is not going to produce an interesting result. Pos.y, some random amount. So you can see here are these things moving around. Now there's only one of them, it looks like. Are there more than one? I can't tell. Yes, there's only one. And it's sort of like stuck onto itself. But if I run this, you can see there's actually two of them. And they're kind of weird, creepy eel things. Well, I don't know if I like them. We can make them friendlier somehow. But you can see now I have multiple things. Now, following a randomly moving point, it's a little bit strange looking, but it does actually work. And maybe this would be better if I made them shorter or changed the design of them. There's so many possibilities here. But what I think that I want to do is I want to do something. This is crazy. I probably shouldn't do this. I wouldn't do it anyway. Before I do that, let's at least just use Perlin noise or something. So I'm going to make two, an x offset and a y offset value for Perlin noise. They're all going to start with like different random Perlin noise. And then what I'm going to do is I'm going to say pos.x equals noise x offset times width, and pos.y, so I'm going to just have them move according to Perlin noise, equals noise y offset times height. So let's see what this does. Now, they're not moving at all because I didn't increase that offset. That offset, which is the value of that moves through the Perlin noise space, so to speak, so I get different values. I'm going to change that now. Boy, almost all of my videos use Perlin noise. Kind of a little bit. So now we can see, oh, okay, they're moving really, really fast. And so let's have them move a bit slower. And so now you can see these eel-like things are kind of exploring according to Perlin noise. Now, I don't know why one of them is like really not moved very far. The Perlin noise actually Perlin noise cluster values tend to cluster around the center. So we're not getting this sort of like full range of motion. If I wanted to do something, I could, if I wanted to sort of see this have a bit more of a dynamic feel to it, I could actually map Perlin noise from 0 to 1 to between negative width and width times 2. And then I could also take the y and negative height times 2. And then, and this should be y. And so now let's take a look at this. And you can see, I don't know where they are, but there's all these little eel things just kind of moving around. And what I could also do now is I can make a lot of them. So I could say for int I equals 0, I is less than 15, I plus plus. And now we've got a lot of these things moving all around the screen. Now, I don't know. I don't know if I like this or why I did this, but you can see these steps, and I think it's really up to you to sort of figure out why you're doing this, what kind of simulation, and really the design of the creature. I think there's so many possibilities I haven't explored here in terms of shapes, imagery, color, character elements. I think there's a lot of possibilities in what you could do. I will say that I think what would be a good exercise, if I go to some of my examples here from Nature of Code. For example, this is what I was thinking of doing. If I went here to agents and took a look at this, flocking example, just as one possibility, is what if I were to use this flocking example, but instead of having these triangles, have these eel-like creatures that are using the inverse kinematics for their body. So now you can see some possibilities of using inverse kinematics in creating a creature. But I think I kind of went astray here a little bit. And I'm going to follow up and do one more video where what I do is I attach the base of inverse kinematics to I attach the base so the base can't move, as if that inverse kinematic system were actually a robot arm and it needed to reach out and pick something up and move it somewhere else. So how would you actually do that? So that's what I'm going to look in the next video, and people in the chat are saying I've made them scared. I mean, maybe I'll come back and redo this video with a more delightful, colorful color scheme. But for now, this was all I got for you. Okay. Sorry, everybody. Let's move on. Let's move on from the squigglies. And I don't know, everybody. Where's processing? Let's go File, Open Recent. I would like to open not the squigglies. All right, hold on. Open. Where is it? Oh, for some reason they're all in this folder. Date modified, Inverse Kinematics. Okay. So what I'm going to do to this right now, before I get into the next video, is I'm going to back up the code a little bit. I'm going to just call this like robot arm or whatever. I don't know, that's a bad. Let's just do Inverse Kinematics too. Okay, and what I'm going to do is I am going to make them a bit longer, have fewer of them. I am going to, for now, get rid of the piece that changes the stroke weight. Okay, so I just have this, and actually I just want it, I think what I also want is the segments getting shorter, or they're the same length? They're the same length. What I want to do is make them longer, and I just want to have like 4 of them, or 3 of them. Okay, so I just want to do this, because I think this will demonstrate the arm thing a bit better. Okay, and they'll be less creepy. Okay. Okay. It has some personality there. Okay. Mumble, mumble, tentacle, tentacle. Okay. Oh, do I need to be? I need to be more hydrated. Okay. Let's think about this. Oh, angle constraints. That's a good idea also. I have to think about this one. First, I want to lock down the base. Cameras will need attention soon. Thank you, Alka. I will press that. You know what? I've been told now, I've been avoiding installing Magic Lantern on people playing like a drinking game along with the coding train. I really shouldn't look at the chat. I should let everybody just have their fun in the chat. I should look at the chat to answer questions at certain times. Whoops. But I think I let it distract me a bit too much, and it fills my head with worry that I'm okay. So hello, probably apples. Looks like we got a new person in the Slack channel. Ooh, you know what kind of apples are really delicious? What are those called? Oh, Honeycrisp, I think. They're kind of rare or something. You can only get them certain times a year. Quite good. I like a good Fuji apple also. Quite delicious. Quite delicious. Okay. All right. Now, I'm thinking about this. Okay. So what I'm going to do, let's make these a bit longer. I'm going to refactor this code also. There we go. I like this now. And okay. These could be watched in any order. Okay. Here we go. This channel is cringe. Indeed. All right. Let me look at my... Oh, people are tweeting me questions. Oh, no, I can't answer that one. No, can't answer that one. Okay, no. I was going to maybe try to see if I could answer some coding questions that are sent to me just here. Oh, there's also stickers. I'm like a walking merchandise store here. Okay, now, what was I going to say? I forgot. Let's do this video because I really want to do the waving flag thing, and I'm slowly running out of time. So here we go. One more of these. Okay. I know. I really want a zipper coding train thing. I don't like the ones without the zipper, but it's hard. American Apparel is out of business. There's all sorts of problems. Anyway, okay. This dot sticker, indeed. Okay. All right. Hello. In this video, I'm going to build on my inverse kinematics example where this strange thing follows the mouse. And what I'm going to do is instead of letting it follow the mouse, I'm going to take the bottom, this part right here, I'm going to attach it somewhere so it can never move. And this is actually what a physical robot arm would have to do. A physical robot arm would be attached to a table or something, and you would have to figure out if you want it to pick up an apple, so to speak, over here, well, you need to put the front over there and then back up and figure out where all the other pieces should go. And what if the apple is out of reach? Well, it's going to reach as far as it can, but not actually get it. So I think this could result in some interesting possibilities. And if I get it to do that and then package it into an object and put a bunch of these onto the screen. So let's see if we can do this and make a little floor of our whole set of robot arms, and I'm sure you'll come up with some creative ideas. Now, this is exactly the same example that I built in the previous Inverse Kinematics challenge. However, the differences are I've just reduced it to 4 segments. Well, actually, it's only 3 segments. And I've took away some of the things that made it kind of creepy looking, where the segments all get kind of thinner as it gets towards the end. It gives it more of a snake-like or eel-like quality. But here I want it to feel more like more like an arm or a robot arm, or I don't know what I want it to feel like, but it's whatever, that's what it is. Oh God, please, somebody save me from this place that I'm in. Okay, so what do I need to do? So one thing is, okay, big deal. All I need to do is, I'm starting from the end, right? Tentacle, if I bring this up again, there are 4, and I think maybe, you know what I think I need to do? I think I need the whiteboard. Because I kind of don't know. I think what I'm going to do is going to work. But I'm not entirely sure. And I'm sure I'll get some help from the chat. People are watching this live. Okay, so what I have right now is this is a target. And I have this. Oh, you know, the thing would be to look at is not draw these things as lines, but as shapes that you have to rotate. Because that's going to give you a lot more visual possibilities. So that's something I should do at some point too. Or maybe you could do that as like a little exercise for yourself. So let's say this is the base and it can never move from here. Well, we know that the algorithm that I have takes this and places it here. Oh, no, sorry. It points it in that direction and then places it there. So what I can actually do, it's going to sound silly, but I think what will work is if this is where it is, the next moment in time, I'm just going to draw the next frame. This is going to point this way and then be here. So it'll be here. This is going to point towards the end of this and then move there. So it'll probably be something like here. Then this would be here. And then this would be, oh no, this is going to point down too. It's going to do some stuff like this, but it's going to be, and the base is over here. And then all I need to do is slide this back and then attach everything again. And as it does that iteratively over time, because then it's going to have to keep pointing, it's going to work itself out. I'm pretty sure that's how it's going to work. I did a terrible job explaining that. So let's try the code and we're going to come back. I think this is going to work, right? You need to do the same thing, but after it figures it all out, I just need to shift it back, basically. You'll see. Okay, so what do I mean by that? So I need there to be a base. So I'm going to make that a p vector. I'm going to call that base. And the base I'm going to have, for lack of a better idea, I'm going to have it be the center in the middle and at the bottom. So what I'm going to do just as a really simple thing is, okay, so once I go through everything, I start with the end, tentacle is the end, and I go through everything, and eventually next is null. So I want to be able to save the last one because I need that first one. I mean, I could just save that in a different, right? I could save that. This is the first. So this is the base. So you know what I could do? Segment. This is really the segment end. And this is the segment beginning. I don't know what a better word for that is. Start. bottom, I don't know. So this is really the start. I'll make that just a variable, and then I don't have to like get it anymore. And then, oh no, sorry. And then this, then I need to have this current start with the start. So I just changed it. What I did is I want to be able to reference the end sometimes when I iterate over it. I want to be able to reference the beginning sometimes when I iterate over it. So the end I'm saving because it's the very last thing as I build the structure, and the beginning is the very first thing. So now I'm saving them both. Okay, so now what I'm going to do is this should say end follow, end update, end show, and then iterate over everything else. And now what I want to do is I just want to say start, is this really right? Start dot A equals dot set to the base. So this is a little bit of convoluted, but A and B, in A is always the beginning, B is the end. So I want to set A to the base. Bear with me here for a second. So see what this does? Wow. Okay, so I guess it gets reset before, so I wanted to see only the start at the bottom, but it gets reset because of where I'm drawing it. So if I were to just for the sake of argument, write it down to do the demonstration that I want to do, which might be useful later. I'm going to take out show from this, and I'm going to only do show here. And this is a little bit silly, but I'm just going to do this. Okay, so now I'm going to do all the updating, set A to the base, and then draw it. Just to demonstrate, ooh, that didn't work. Oh, I forgot. I have to have this loop iterate to the next one. I think an array would really make this. So now you can see that the base, but this isn't right? Look at this, because it can stretch forever. So this is not all right. It's like a trick that A is always there, but it's not really there. So now what I need to do, if I set A to the base, I also need to say update, what does it calculate B? So it needs to also find its endpoint. Right, so that's really what it's doing, right? So now it's getting set there. All I need to do once it calculates its endpoint is I need the next one to be locked to that one's endpoint. So that's all I need to do. I need to make sure the first one is locked to the base and it recalculates its endpoint, and then the next one is locked to that one. So what I can actually do here is, and I'm going to think if there's a better way to do this, but I want to say, I'm going to do another loop where I start now from start. And then, as long as next is not equal to null, what I'm going to do is I am going to say next dot a dot set, okay, previous. So wait, I need to keep track. You know what I need to do? Oh, it has it built into itself because it knows its own child. No problem. So we should make this a function. So I'm going to leave it that way. We're going to say next dot, I don't know what to call this, like connect, retract, go back, attach to, I'm going to call it attach to child because that's what it really is. I'm going to write a function like that and then say next equals next dot child and go to the next one. So what does it need to do? And this is just for drawing it down there. What does it need to do when it attaches to, oh no, sorry, this is not a function. What does it need to do when it attaches to the child? Exactly this. So if I add this function now that says attach to child, yeah, me I am so me is making a great point in the chat that these vector objects, I could have both pointing to the same vector, so when that one moves, it actually does it automatically. And I think that would be a great refactoring optimization of this. What a good point. So I would love if someone wants to try to implement that. I think I'm going to leave it the way that I'm doing it for right now, which has a lot of flaws in it for sure, but hopefully you're getting the sense of some possibilities here. So attached to child, what I want to do is, all of these I think I really need to refactor. Maybe I'll come back and show you a refactored version of them. Is I want to say, basically, what I did here, which is, and I'm gonna write a function, which is I'm gonna call it set B, because B gets attached to the next A. Set B based on an A, and I'm going to say b equals a dot copy. So I'm going to write a function called setB. This will make things much simpler because I can just say start setB to the base. Oh wait, but the a gets set. No. Oh my goodness. So confusing. Because, okay, whoa. Hold up, everybody. This is so confusing, right? Because you're stuck in this world of like, okay, do I want, this is A, and this is B, and this is A, and this is B. Do I want to say A set it to B, or do I want to say B set it to A? Or do I want to say put B in A? Actually, there's a way that I want to do this. I really want it to, I'm always setting A. I'm setting A according to the base, or I'm setting A according to the previous one's B. So is it really its child? No, it's its parent. So I go to the child and it takes the B from its parent. What am I doing here? Inverse. That's definitely wrong. So it's not attaching to the child, it's attaching to the parent. I'm just going to call it attach. So I'm going to go back here. So what it's doing is, I'm only setting A, right? I want to set A to some, and I'm just going to call it a position, just to make it kind of more generic. I want to set A to some vector position. And so I want to set A to the base. Then it needs to calculate its B. Then I'm going to go to the next one and say attach, I'm going to say attach A. And it's going to move to the next one, which is its child, but it needs to attach backwards to its parent. So now, when I say attach A, in here, and boy could I make this a little bit less awkward to look at. I'm going to say set A parent dot B. So yeah, I clearly could condense these functions. This is kind of a little bit of overkill, but I have a function that takes a vector and puts it in A, and now I want to have A attached to its parent B. There we go. So now, I believe, oh, what did I do here? Parent.b. What if it doesn't have a parent? I thought it should be fine. No. The next one is, I don't want to do this with start, right? I mean, I could, I want to do this with start's child. So I've got to move to the, I want to set the first one to the base and then move to the next one immediately. Yeah, everyone in the chat is saying this is crazy overkill. So this is right, but it's wrong. Because what did I forget to do? I forgot to update. I have really over-engineered this. I usually don't do this. Calculate B. I'm like, what's this last one is able to separate. Why is that? Okay, let's think about this. Okay. I'm so sad. I kind of want to, I feel like I've really ruined this. So I feel like I'm going to start over. Let's make this work, and then I'm going to do this again. Because no one's going to want to watch this nonsense of this crazy over-engineered all these functions. End is following mouse. And so I want to just see that this works, and then I'm gonna think about this, and you guys are watching the live stream will have the benefit of watching this horrific thing. Oh God, it's 7 o'clock already. Okay. Why is this separating? So it must be that I'm not getting through everything. If next is not null, attach A to its parent and calculate its B and go to the next one. You will have to check to see if the distance to the point is greater than the total. No, I shouldn't have to check. They're all going to get back. They're all going to get set back. I guess, because of this. This show is here. This is the problem. Boy, I really botched this. An array would just make this so much simpler. I'm gonna use an array. Yeah, I'm going to start over and use an array. So it works. It was the right thing. So this is what I'm talking about. This is it. Okay, so yay! Wah, wah, where's the sad trombone? Oh, it's like 77 degrees in here. You could solve it, make a zero length segment. Okay, so I did get it to work, which I'm pleased with, but I really think that this like linking child and parent and everything, it's in an order. It's in an order. Why am I avoiding having an array? This is clearly a point where having an array will like get rid of all this soup. So, unfortunately for all of you, you're about to watch me do this again. And I'm going to save this, and I'm going to close it, and I'm going to go to, I don't know where, somewhere, here. It's time for an array. Oh, right. Oh, so sad. Because, okay, we're going to have to do this again. I'm going to save this to Inverse Kinematics 3. And I made just 3 things. And they're all like 100. And in the segment, I got rid of the stroke weight. And I don't need this. So this should be back to this. Okay, 3 things. Okay, here we go. So tiny, this window. Let's make it 800 by 600. This will give us more room to work with here. Okay, I kind of also like Me's suggestion of this is a why should you use arrays video all along. Yeah, okay. So, boy, it's really good. The one issue is I might have to take a little bathroom break here because I've been drinking a lot of water. But, you know, I do have an issue where sometimes after I do these long live streams, my throat really hurts. And so I think drinking a lot of water will help that. Okay. We are going to use a, I'm going to refactor this with an array. And I'm going to get rid of the parent-child thing because I'm just going to move backwards and forwards through the array. It's going to make things much easier. Yeah, so, and Me is also pointing out something really useful, which is that I could do all this as just an array of p-vectors. Like, I don't need this object-oriented stuff, but I do want to keep that because I think the object-oriented stuff is a foundation for really playing with the visual quality. Because if I have the segments as objects, I can start to associate colors or images or rotations and other things with them. So I think that will be good for the long run. But certainly, you know, what I'm doing is just this exact example that's in processing already. And if you look at it, you're going to really want to complain about my code, my terrible code. So where is that? Where is that? Basics. Interaction or topics, interaction, reach. Really what I'm doing is this. And this is Keith Peters' example. So if you look at this, this is exactly what I'm doing. The difference being it's just an array of x's, an array of y's, and an array of angles. But I really like taking a more object-oriented approach. Okay. So whiteboard. What about the whiteboard? Oh, you mean I need to like erase it because I already have stuff there? Okay, let's do that. Is that what you're telling me? You could release it as a video of how not to program it. Okay, here we go. So let me get myself ready and I'm going to start this over. Attempt number 2. Okay, here we go. You guys ready for this? This is going to work better. I'm also thinking about a person in the back of my mind who asked about this video. I'm like, oh my God, I can't send them that. All right. Hello, we're pulling into the station, the kinematic station. And what I want to do is I want to expand my previous inverse kinematics example. I don't know if expand is the right word, but I want to change the way it works in a way. So first of all, this is the exact same example that I built in a previous coding challenge, but I've changed a few things. I've gotten rid of the there's only a few segments now. There's only 3 segments. The segments are longer. And I've also gotten rid of that thing where the stroke weight of the segments changes. So it has less of an eel or a snake-like quality to it now. And it's just kind of has more of a robot arm-like quality. Because what I want to look at is what happens if I take the base of it, this right, and lock it to a certain point. Much like an actual real robot arm would do. So what if you need to figure out the kinematics for a robot arm to reach out and grab an apple because the robot likes apples? That would be a great robot. People should make just robots that like apples. Anyway, I had a point to this, which was, and so how would you do that? And so this is how we're going to do it. Now, first of all, I've got a little secret to tell you. I actually just tried to do this, and I completely over-engineered and wrote some really spaghetti problematic code. I will link to the live stream where I did that, and through writing that code, I really realized this is a time where it's just going to be so much easier if I just use an array. So it's kind of interesting to explore this problem as this kind of linked list thing where each object keeps track of its parent and its child, and I did that in the forward kinematics, but it's kind of unnecessary because the segments are just in an order. And if they're in an array, all I ever want to do is iterate through them forwards or backwards and know which ones are next to each other. And an array is going to just make that so much easier. So let's talk about what I mean by that. So remember, this is what inverse kinematics does. So let's say this is the sequence of segments, and this is a particular target. Let's put the target up here. This is a particular target. So what this segment in the previous example is going to do is it's going to turn to point at the top target. So it would do this, and then it will shift its position all the way to here. This is if it can, if the base is not locked and it can move. Then this one will turn to face the beginning of that, and then it will move to there. So that's what we did. So what we're going to do to lock the base, and this sounds like overly simplistic, but it works from what I understand, is I'm going to do that with all of the pieces. So maybe I get this one here and this one here, and then after I do that, I have kind of a new arrangement, and then I shift the whole thing back. So just shift the whole thing back, we're done. I'm going to move this back here, then move this, then move this. And there's probably some very easy ways to do that. I'm not so sure if I'm going to end up doing it the simplest way. I'm sure, this is really, today feels like a lesson in refactoring, which is, just writing the code to get it to work and then reorganizing and simplifying it and trying to do that a little bit. But so this is the basic idea. So let's start going to the code and let's make an array that each one of these segments has an index into that array. 0, 1, 2, and 3. 0, 1, 2, and 3. This way, I could just do inverse kinematics by iterating over this way, and if I need to iterate through it forward, I can do that way. I always know the base is 0, and the last one is in the length of the array minus 1. It's going to make things so much simpler. Okay, let's try this. Here I am. Okay, so I'm going to make an array, and I'm going to call it let's call it tentacle. It's fine. The array is still called tentacle, and I'm going to say tentacle index 0 is a new segment. So I make the first one here, and then it's probably still useful to have them keep track of their parent. I don't know how necessary that is. Let's actually comment that out right now. Actually, let's keep the parent thing because that is a way that I position the next one, which is kind of useful. So let me keep that for a second. Bear with me. So I'm gonna get rid of the child thing. I sort of have a suspicion that keeping the parent might be useful, but the child thing is kind of unnecessary, but I don't think I'm using that. So I'm just going to refactor it to do the same thing first. Then what I'm going to do is I'm going to have this loop start at index 1. So I'm going to go from 1 to 3, and I'm going to say tentacle now index I, and I cannot spell tentacle. Tentacle index I is a new segment made from tentacle index I minus 1, which is the previous one. Oh, this is so much better. Forget about the child thing, forget about next. Forget about this. Look at this. Oh, I feel so relieved. Oh, I feel so relaxed now, thank goodness. Oh, this makes so much more sense to me. Okay, so now we've got our array. And then what should follow the mouse? So tentacle, so I'm going to just say end is tentacle length minus 1. So the tentacle and actually let's have that be a segment, is the array, the last spot in the array. I could use an array list and use pop, or there's probably some other fancy way to do this. I cannot spell tentacle, it's such a hard word to spell. Okay, so that's the end segment. And so now I just say end follows the mouse, and I'm going to move over here a little bit. End update end dot show. Okay, I don't know that I need to do it all this way because ultimately I'm going to loop through everything. But now what I do is I want to iterate through them backwards. So what I want to do is say for, sorry everybody, I've got a little sound thing going on here. For, I want to start at the end of the array, I equals, I just want this to be in a variable. Int length, int total, because this is going to make my life, I'm really now trying to make the code simple. Total is tentacle.length, and so the last element is total minus 1. And I'm going to start from total minus 1. No, I'm not starting from total minus 1. I'm starting from total minus 2. Go all the way down to 0, I minus minus. And then what I'm going to do is say tentacle index I follow update show. And the reason why this is useful is follow knows how to, it follows its child. So that's the relationship that I need, not the parent, it seems. But you know what? Guess what? I don't need the child because I can tell it which thing to follow. Right? What if I just give it a segment to follow? And then here, I know what its child is. You know what its child is? It's tentacle I plus 1. It's the one after it. So this is so much nicer because I don't ever have to keep all these references because I can just have them, I know that the one after it is the one that it should follow. Great, so this should be the same. Oh, I have a mistake, which is no surprise. It would be nice if I actually created the array. In Java, you've got to be quite strict about these things, and I want an array with, how many things do I want? 3 total? And I want to say tentacle.length. And it's not an array of tentacle objects. It's an array. It's very confusing, but it's an array. The array is called tentacle. The objects in it are segments. Okay. Yes. There we go. Look, I've got the same exact thing, but I just feel so much happier about the code. I feel so much less stressed out. Now, one thing is, did I use parent anywhere? Do I use parent anywhere? Not really. I mean, I use it here in that that's how I get its initial location. But I don't use it anywhere else. So I can pass it in, but I don't actually need a reference to it, just to simplify things. Okay. Okay. Okay, so now I've really made things so much simpler. I feel so much happier. So now what I can do is I can introduce this idea of a base. And what I mean by base is where the thing is attached, fixed. So I want to have it be attached to the bottom. So I'm going to create an object called a p vector object, which is the base. And I'm going to set the base to be equal to a new p vector, which is in the middle and at the bottom. Okay? There we go. A new p vector, which is in the middle at the bottom. Yay! Okay, feeling good about this. Then what I'm going to do is, after I do all this nonsense, I want the thing in the array that's first, the first element, which is tentacle 0, and I want to set its location, set A, its start and end point. I want to set A to the base. So I want A to be the base. And so I'm going to write a function called, and actually I think I want to put this function near calculate B, set A, and it's a little bit, this is a little bit overkill to just have a function just to do this. But I'm going to say A equal, but I'm doing this because, you know, I think there's a way to have the object's endpoint always, one object's endpoint always has to be the other object's beginning point. So I think I could probably link those. But I'm a little bit afraid to do that. So I'm going to copy the data, copy this vector to this one just for now. Maybe later we can do that. Okay, so now that I've done that, what I want to do is set its base. Okay, let's do that. Now, okay, so first of all, why don't I, didn't seem to work. Well, setting it as its base doesn't really do anything because up here, as soon as I update it, it's going to attach to the thing that's moving. So one thing is I want to, I think I want to just take out show here, and I want to have a separate function for rendering everything because that's just going to make everything much, much easier to deal with. So if I do that, we can see that this works. But look, this is not a realistic robot arm because the bottom can just stretch to wherever it needs to go. Because all I've done is set the base to the bottom, but I didn't change B. So what I need to do is whenever I change A, I need to also update B, which gets done in this function calculate B, right? Remember, it uses that polar to Cartesian coordinate transformation to set B based on where A is and the angle. So now that I do that, you can see, well, it's attached to the base, but the rest of the stuff could just go and do whatever it wants. So now, what I'm going to do, and some people are asking why not use a for each loop, and I do. You do see me use this enhanced loop in Java, but the reason I don't want to do this now is because precisely this. I want to now say, for int I equals 1, I is less than total, I plus plus. I want now tentacle index I set A to tentacle index I minus 1. I need dot, let me just type this in here, dot B, right? What is this doing? What did I miss? That's total, it's tentacle. I want to say, and again, this could maybe happen if they both pointed to the same data. I'm copying the data, but what I'm doing here, oh, shoot. Little edit point, thank you, edit, Mathieu. Okay, do this again. What I want to do is I need, when they're detached, I need this one's A to be set to the previous one's B. And remember, they're ordered like this in the array. So that's what I'm doing here. So I think this is a much nicer solution to just say set index I have its A be equal to I minus 1's B. I think I did this right. I want to play like a drum roll or something, but let's just see. There we go. Look at this. So now I have this robot arm that's following the mouse. You can see that it's always, if my mouse is an apple, it's going to reach up to pick it. Now it can't go very far. I could easily make the segments longer. I could make the segments longer. Well, how would I do that? I could make them, oh no, so first of all, let's add something. Let's say length. Is length a variable somewhere? Let's make them 200. And let's also figure out, up here is how many segments I want. So we could see here, this is what it looks like, right? If the segments are, let's try another length, 300, there's probably nowhere in this pixel space that I can't reach. Now, I don't know what it is exactly that I'm doing. And I think it might be a little bit more interesting to look at this if they were actually smaller and that there were a lot of them. And here now we can see, whoa, there's 30 of them, but they're really small. Let's make them a little bit twice as long. So you can see now I've got this thing that's kind of reaching to try to catch up. And you can see, you could imagine, now here's the thing. What if where the mouse is, what if it's following not the mouse, but what if it's following some oscillating pattern or a bouncing ball or some other physics system? You can see what the possibilities are. So what I'm going to do in the next video is I'm going to take this example and package it into an object, and then I'm going to make a bunch of them that follow some type of sine wave or noise or something to see what that gets. Okay? So I think this video made sense. I'm so happy about using an array, and I'm happy that you watched it. I feel like I wish I had an apple. I've got all this stuff here. I'm going to go have an apple later. I do like apples. Okay, goodbye. All right, it's Mr. Wiggles. I don't know if it's a Mr., but there we go. All right, I feel so glad that I redid that. I don't know why I just committed to doing another video about this. I had an outlandish idea that I said I would come back to. Everyone's asking, it's like everyone in the chat is always asking about neural networks. I'm going to try. I'm not so sure I should, but I'm going to try. Okay, So what I'm going to do is I am now going to check. I'm going to play a little music.
As always, I always forget the this dot, this dot, this dot, this dot.
I'm looking for my phone to make sure there are no emergency messages at this late Friday evening time. Okay. No, I think things are okay. Great. Okay. How's the volume, by the way, of my voice versus the music? I'm always curious about that. Can you hear that? This is my favorite sound effect that for whatever reason you can't hear. Oh, there, it's much louder now. It's really long too. I love a timpani. A good timpani is like a great sound. Okay. Let's see here. I actually just made the sound way, way louder, so the mix probably is not good one side. All right, so let me see here. Let's go on. I got to just keep moving. Here we go. Okay, I'm back. This is my friend, the tentacle. It's quite a nice, friendly tentacle. I feel like you hopefully could make something where the tentacle's a bit more colorful. Maybe it has some cute eyes and it smiles and it reaches for an apple and then hands it to somebody else because somebody else could use an apple and then they're going to be happy. You should go and do all that stuff. What I'm going to do in this video is I want to take all this gobbledygook, all this code that is in the main program here, and I want to put it in an object. And I kind of did this before. I want to put it in an object in order to, why do I want to do this? Because I want to make more than one of these tentacle things. So right now I have this organizational structure where there's a segment, and a segment is one piece of a tentacle. The tentacle is an array of segments. So I actually want to make a tentacle object which has that array. So what I'm going to do is I'm going to make a new tab. I'm going to call it tentacle. And this is going to be the easy part. I'm going to say class tentacle. Boy, I'm having like a crazy deja vu here. And what I'm going to do is I'm going to say, what is a tentacle? It needs these three things. It needs an array, it needs a base, and it needs a length for the segments. And obviously you can vary that to your heart's content. I'm going to take all of this stuff and put this in the constructor for this object, for this class. Whoops. So now when I make it, I create all this stuff. And this is going to be really good because what I'm going to do is I'm going to, when I make the constructor, I'm going to be able to set its base. I don't know why I'm putting this first, but so the idea is the tentacles are all the same. Now I could give it more, this you should do, right? I should give I'm going to make a tentacle and say, how many segments, the length of the segments, your color. I could vary it in a lot of ways, but I'm going to keep things simple here. Then what I'm going to do is I'm going to look at all this code, and I'm pretty sure basically everything is can go in an update function. So I'm just putting everything. I could separate out some of this logic, but I'm doing the thing where I have it follow the mouse, and then I have it, what do I have it do after that? Then I update all its locations, then I set it backwards to its base. I do all that, and then I'm going to write a function. And I'm going to call it show, and it just iterates through the array and show. And this is a place where I could use an enhanced loop. People like it when I discuss different kinds of loops. So I'm going to say tentacle t in tentacle. And I kind of want to call this segments because I think it's a little confusing to call that tentacle. So I'm going to change that also. I'm going to try something kind of crazy. And I'm going to say t.show. Okay, let's just see if this works. Well, whoops. What did I do here? I think I messed something up. Tentacle t in, I didn't spell it right. No, I did. What's going on here? This segment tentacle is a new array of segments. What does it not know why that is? Why does it not know what that is? Oh, this is a segment. See, this is why it's so confusing. I've got to be really clear about this, right? Every segment S, this is why I want to change. So I'm going to run this. And now, I'm going to refactor this in a second. I'm going to show you something kind of cool that I think you can do in processing now. So I'm going to now make a tentacle t. I really should have thought of something besides tentacle. Tentacle. I'm going to give it a base, width divided by 2 height. Then I'm just going to say t.update and t.show. And now I have a single one. This is just the same exact code, But I have now refactored it, so this tentacle lives somewhere else. It lives in, all the code lives inside an object. Now, what did I want to show you? Here's the thing. I really don't like that I named this tentacle. It's causing me to be confused because it's an array of segments. I think I should just call it segments. So one thing I can do is I can go here and I can do rename. Look at that, rename. Now, obviously, I could just click on this and type a new name. But what the rename tool in processing does is it finds all the other places you use that variable. It's not a find and replace of the word. It actually is able to look to where the variable is being used. So in a comment, it wouldn't change. So let's hope this works. Rename. I've never actually used this. Segments. Oh my god! Ta-da! I don't have my da-da sound effect. Okay, that's really exciting. That worked. That is brilliant. I love that. That makes me so happy. Okay, so now I've renamed it. I feel like this is a bit easier to follow. Okay, so great. Goodbye. No, there's more. What I want to do now is, I don't know what I want to do exactly, but let's try, I don't know what's going to be interesting. I kind of want to put them in a pattern. What if I put them all around the edges of a circle? That's kind of crazy. So what if I made an array list of tentacle objects? Do I really have to call this tentacles? I think I do. And tentacles is a new array list of tentacle. And I'm not going to add anything right now or do anything. I'm going to comment this out. So what I want to do is I want to say I'm going to make a little circle. A equals 0, A is less than 2 pi, A plus equals 2 pi. Let's see. What's our change in angle is 2 pi divided, let's have 10 of them, divided by 10. This is like a weird idea that I'm doing. I have no idea if this is going to be any good. You're going to have a much more creative idea of why you want to do this. And then I'm going to say, give me an x. Give me an x. And x is the center of the screen plus cosine of that angle times 100. So I'm just going to place all these points around a circle. And a y is the center of the screen plus sine of the angle, a height divided by 2. And then what I'm going to do is I'm going to say tentacles.push a new tentacle at x comma y. So I just used, again, that same polar to Cartesian thing to get all the points around a circle. I'm using that. Perlin noise and polar to Cartesian, I need little, that's all I ever do, I guess, basically. And it's not push, because that's JavaScript. With an array list, it's add. And then now I can go down here and I can say for every tentacle t in tentacles. And I can get my update and show, update and show back. And I can run this, and you can see, whoa, look at this. So I got all these tentacles starting, and they're all following the mouse. Now, this is kind of interesting. I think there's probably a lot of possible ways you could expand on this. One idea I have, first of all, is to not have them follow the mouse. I could have them follow a Perlin noise moving thing. I could oscillate their endpoints. Really what I probably would want to do is give them each their own thing to follow that's kind of around the edges, depending on what side they are. I think I might want to stop here now. But I do think it's worth kind of noting, actually, what we could do is, and actually, I think this might be more interesting if the tentacles themselves were not so long. So I'm going to make them actually only have 10 segments, right? And they're still quite good. I don't know what this looks like something. And I kind of want also them to maybe be further apart. Right, so you can see this. I don't know what I've done here. Now I also want to draw, I don't know what I'm making. I want to draw an ellipse. Just want to be able to see the sort of circle, which is 400 by 400. So, and I guess I better say no fill. There's probably a clever way I could constrain them. So you can see what I'm doing here. You could imagine this is the beginnings of the design of some creature. Now, since they're all pointing towards the mouse, you're getting a very kind of specific thing. It looks kind of like a spider web, kind of like noodles. But one thing, since we said robot arm, let's get them to try to pick up something. And I want to make it appear a bit more obvious what I'm doing. So I'm going to make the length of these 50, and I'm going to give them just 4 segments. So now you can see they're much more robot arm-like. And actually, I don't know what I'm doing exactly, but I just want to have 5 of them. Let's try that. Okay. And maybe I'll let them even be a little bit longer. Like, what if I give them, I'm losing my mind here, because there's really no point to what I'm doing. Okay. So what I want to do is I'm going to just say, let's make a particle. And I should really make this an object, but I'm just going to give it a position. And position equals new p vector. I'm going to just start it I'm going to start it at 0, 0. And I'm also going to make a velocity. And I'm going to say velocity is a new p vector, which points, 2, 1.3, just to give it something arbitrary. And I'm going to say now, position.add velocity, and I'm going to position.add velocity, and I'm going to draw a little circle at position.x. This is going to be the apple. Position.x, position.y, 16. Imagine this. I guess I could make it kind of green, a green apple. Would it be like, I don't know, is that a color of an apple? So I'm going to do this. You can see there's my apple, and I'm going to say no stroke, and I'm going to make it a little bit bigger, and there's the apple. You can see it moving along. So what I want to do now is have these arms follow the apple. And I feel like the apple should, I want to give it gravity and have it bounce around. Oh, there's so much stuff that I want to do that I'm not going to do. But I will have it move a little bit faster. So now what I need to do is just say, okay, if position.x is greater than width, or position.x is less than 0, we're just going to make it bounce. Velocity.x, multiply it by -1. And then we'll do the same thing with y, because why not? And then we're going to add gravity to this, because we have to. So now we can see there's the apple. It's moving very slowly. Let's increase its velocity by 3 times. So you can see, so let's see, it should move, it should bounce. What did I have? I have a mistake. Greater than height. It didn't bounce off the bottom. So let's see that apple. It's going to head towards the bottom. It's going to bounce around. So why am I doing this? Is because now I could have my tentacles follow that particle. So you can see they're all trying to kind of grab it, and I don't know whether they're throwing it or passing it or whatever, but you can kind of see what's going on. I feel like it's sort of, the positioning of it is kind of weird. I think this would be more interesting if they were positioned all along the edges, and also if the ball did something a little bit more interesting, like if it actually had a force, like gravity. And if I said gravity is a new p vector that points, down by some amount, and then the velocity always changes by the gravity, and then also I should probably, this is going to cause a problem. I should also say if pos.y is greater than height. This is a little thing that I'm going to just scooch it back onto the screen because it can kind of get stuck. I don't see the gravity happening here. Why not? Or is it just so weak? Yeah, I think it's there. It's also, we don't need to actually check it. If there's gravity, I don't need to check the top anymore. So this is what I meant to do. I can just scooch it back on when it hits the bottom. So come back. So you can see it's bouncing, and I could add some dampening. Let's add some dampening. I'm really off in like physics land here for no good reason. Everyone's probably stopped watching this video by now. No one's going to see my end screen. Oh, that's so much dampening. So I can add a little dampening so it kind of like slows down. And you know what would make sense is only have the dampening happen when it hits the bottom. So maybe that would make more sense. Okay, so you get the idea. But Probably Apples in the chat. There's actually a person named Probably Apples in the chat says, I might be wrong. Just spitballing here. Who knows? I mean, I just might be wrong. But I don't think this is Probably Apple's voice. It's my voice. But probably apples don't bounce around like that. And I think that's a very good point. So I almost feel like this will be more interesting to watch if there were only 2 of them and if they were further apart. So hold on, just bear with me for a second. What I'm going to do is, where do I make the tentacles? I'm going to have just 2 of them, and I'm going to make this 300. This is silly because there's no point in a circle. Yeah. So look at this. Now it looks like they're playing catch. which they aren't, but it's kind of interesting. So there you go. Here is my Inverse Kinematics robot arms playing catch with an apple on the coding train. I really want to say a special thank you again to Keith Peters and Coding Math. These examples are really essentially exactly the same as the examples that are right here. And you know what, I'm realizing I better show this one because I think I'm getting this idea. I know I'm getting this idea from exactly this. So this is Keith Peters' example that is in the processing. My code is quite different because mine is in an object-oriented fashion, but this is there, and you can see there's some variations in terms of segments and how they're working. So there's great suggestions in the chat. I could do things about constraining the angles. I could make them not intersectable. There's lots of things I could expand this. I could think about design. There's so many possible things that I could do to expand this. So thank you. Check out the Coding Math channel. If you want to see somebody who knows what they're doing about math and coding, that's a channel you should watch. Great examples, great inspiration. And you can see here we have our robot arms playing catch. Thanks very much, and I'll see you in a future episode of The Coding Train. All right, there we go. How am I doing here? It's 7:40. Please make them affect the apple when they touch it. That's a great idea. So you guys, Perl and noise, all these things I could do. So this is the thing. This is one of the reasons why I do these examples. It's so tempting for me to just like add every possible feature idea to it, which is kind of fun. And maybe there's some times where I could do that more. But really what I personally enjoy about this is making these examples and seeing what the community does to expand them and make sort of fun, interesting projects. Okay. So Inside the Matrix asks, can I fill an ellipse with an image in processing? How? Well, it's funny you should ask that, because this is the next thing that I want to do. So filling an ellipse with an image, I would probably honestly just make your image a transparent PNG, and that's circular in the middle. But you could use the mask function to do that. But I'm going to show you something about texturing next. Okay, so first thing I need to do, let's get rid of that. And mugs, t-shirts, did I mention that? Okay, now dribbling is kind of fun. Okay, now what do I want to do? I've got to get going soon. I'm basically, MWT Bones writes, he's basically giving you homework, kids. Don't trust this man. Now, first of all, you should trust me because, I don't know if you should trust me or not, but I have good, my intentions are good. I just want to make examples and make things that you enjoy and hopefully learn something from them. Whoa, okay, 10,000 steps. But you definitely shouldn't trust me in terms of what I'm doing programming-wise, because I'm just like messing around, I'm always making mistakes, and who knows what I'm doing. But you, I bet, watching this, can take my examples and improve on them and let me know how you did that. And you should trust yourself in that sense. Okay, now. Here we go. Okay, so what am I doing here? I got to get something out here. So what I'm going to do is I'm going to, I don't know of a better way to do this. Let's go to Rainbow Code. This is the last thing I'm going to do today. Really want to get to some processing and Eclipse tutorials. When is that going to happen? Is it ridiculous for me to download this whole thing? It's probably a huge file. I am on the fast network though, so I think it's going to come through fast. Is this? No, that's fine. It's not coming through as fast as I thought it would. Let me just look. I must have this somewhere. I could clone. Is cloning it going to be faster? I want to get one of my old coding challenges, which is called, I know what I can do. Where's the cloth simulation? Cloth 3D. Here we go. Boy, today's really a processing day. So by the way, anybody who wants, I like to keep a P5, when possible, I like to have a P5 and a processing version of every challenge. So if anybody, once I post the code, wants to pull request to port to P5, I'd be thrilled for that. But I will try to get to it myself at some point. So now what I want to do, I don't need to, there we go. Cloth 3D, where are you, Cloth 3D? And I am going to introduce you to somebody. It's not a real person. Hold on a sec. Can I airdrop this? I've got an image here. Here it is. And I am going to see if it'll airdrop to my laptop. Oh, I'm not on the same. Oh, nope. I'm not on the same. Hold on. I know what I need to do. Just bear with me for a second. This is a very silly thing that I'm doing, but it's going to be worth it. Okay. Choo-choo. I now have a password for something, which is choo-choo. It's not anything that you could ever possibly log into. It's a little, but that's a new password I like. No zeros for O's, just actual O's. Okay, now I should be able to, oh, I know why it didn't work. I also have to go, don't I have to do like airdrop or something? Boy, this is like such ridiculous technology. What I need to do is, come on, appear. There we go. Something came in. iPhone 6 train. Did I come? Yes, accept. I'm going to introduce you to Unikitty. This is Unikitty. Unikitty is drawn by my 8-year-old. It's a character, I assume he invented it. It's a kitty and a unicorn. There's more to this drawing, but this is the cropped version of it. There's a rainbow, there's a moon, there's some stars. It's Unikitty. It is a child's drawing, yes. I did not draw this. And what I want to do, I'm going to use Unikitty in my, because I think Unikitty should take off and become a thing. Somebody should make a Unikitty thing. Unikitty songs, t-shirts, everything. I don't know. What I want to do now is get, this one. So now what I'm going to do is open this up. And does this actually work? Okay, great. So this is a coding challenge I did a while back. And it's a cloth simulation. And what I want to do is look at how you texture an image onto a mesh in processing. And so I am going to turn this, what I'm going to do is turn this on its side, attach it to a pole, and make it a flag, and then put the Unikitty on the flag. That's my plan. And so before I do that, I think I'm going to do this in 2 parts. I'm going to do a short tutorial on texturing geometry. I think that's what I'm going to do. And then I'm going to do a challenge. I mean, I guess I could do it all at one video, but maybe let's think about this in 2 parts. Texturing geometry and then Unikitty on the flag. And then I am done for the week. The weekend will begin and I'll be back next Friday. That's kind of my plan. Okay. Now, a globe would be a good idea too, but I'm going to do, so let's see. So first thing I'm going to leave this open. I'm going to save this as coding challenge. I don't know what number this will be, flag. And then I'm going to make a new sketch, which is texturing. And I think I wrote a tutorial at some point that's on the processing website. If I go to tutorials and under 3D maybe. Where is that? P3D. And under texture. Yeah, here we go. So let's look at this tutorial to remind me how this works. So I can make a shape that I can call texture. Then I have to add UV. Okay. Set texture. Okay, there's very little here, but I think I can manage this. All right, let's go to the reference. Let's try this, the texture function. And yeah, so this will help. Okay, this is fine. Okay, so, and what do I need? So I need a texturing example, and I need to have it have a data folder. And where's Unikitty? Where have you gone, Unikitty? Where have you gone, Unikitty? He just found its lonely eyes for you. Ooh. Unikitty. Unikitty, into the data folder you go. And I will put Unikitty into this folder as well. And we should be good to go. Okay. So I don't know where. I guess I could make this like a Q&A. It's not a coding challenge. I don't know what playlist. Sure would be nice if I had a taskbar. By the way, I'm terrible at computers. I really am the worst. I used to be good at it, but I'm just behind the times. Okay, so what do I need to do here? I need to have some. I need to stay hydrated. That's for sure. I need to erase this whiteboard. And I need to, once I start doing this machine learning stuff, I think I'm going to have some shorter live streams because I'm going to need a lot more time to prepare stuff and read up on stuff to be able to have any sense of any ability to do any of it live. Okay. Oh, wrong screen. Okay. So now what am I going to do? I'm going to, okay, I was trying to figure out what playlist this goes in, but I don't know what, I'm going to figure that out later. This is not a coding challenge though. Let me see. I guess it could go in the learning processing playlists. It could just go, whatever, Q&A, who knows? We'll figure that out later. Anybody has any suggestions for what playlist I have that would make sense of just a texturing tutorial? I guess I could think of it as one. Maybe I should just make it a coding challenge all in one with the information, with the sort of like quick texturing tutorial at the beginning. Yeah, that would be fine, because I really need that in order to make it. Okay, we're going to make this one. I'm going to try to make this one coding challenge. If it ends up being in 2 parts, fine. I'll fix it. I'll come back next week and re-record it. Okay. Memories, like the corner of my mind. Is that those lyrics? I'm not sure. You might remember me from, my name is Dan Schiffman. You may remember me from coding challenge number 20. I think it was number 20. 3D cloth simulation. So this is a coding challenge I did a while back, and I would like to update this coding challenge. And one of the things I want to do is put an image onto that cloth. And I want to make it more of a flag simulation. So I want to just sort of, so think about, you could get the flag of your country, and you could texture it onto this cloth thing and have a waving flag simulation. So that's what I'm going to do. But really, underneath the hood here, here's what this coding challenge is about. It's kind of a tutorial about how to texture geometry. So how you can create arbitrary geometry, arbitrary polygons in processing, and then texture them. And so that's with an image. And what I mean by texture, I mean take the pixels of an image and fill the geometry with those pixels as opposed to just fill with a color. So that's what I'm going to start with. And I'm also going to introduce you to a new friend of mine named Unikitty, but I'll get back to that later. So let's go over to the whiteboard for a second. The whiteboard camera is off. I'll say it again. I don't know. Let's go over to the whiteboard again for a second. Not again. Let's go over to the whiteboard for a second. Okay, here I am. And okay, so what am I talking about here? So you can load an image in processing by saying load image. And that image could be a file like file.jpg or file.png. If you call load image and put the results in a variable like img, you can draw that image to your canvas by saying image and then passing in a reference to that variable and give it an x and a y. And then your processing window canvas, you will see the wonderful kitty cat. I cannot draw at all, but that actually wasn't the worst in the world. If that's a kitty cat, right? You're just going to have to bear with me. I'm just going to draw it again, right? There you go. Load the image into a variable, draw it there. That's just drawing the actual rectangular pixels of the image exactly as it is in the file. Something else you can do in processing, however, is you can use functions like begin shape and end shape These are functions for I want to draw my own arbitrary polygon or path. There's a lot of things you can do with begin shape and end shape. It's vast sort of possibilities. But in the simplest level, what I can do in this function is say vertex x comma y. And then I can say vertex again, x comma y. Boy, this pen is terrible. I'm looking around to see if I have another one. Pause. I'm ringing the bell. I'm looking for another pen. I usually keep a bunch up here. Otherwise, I was feeling confident that I would find one, which is why I stopped. But I actually don't see one. Oh well, I'm not going to go all the way downstairs to another floor to get one. So I'm going to go back. I'm back and I don't have another pen, but I will in a future video. So I can set a bunch of vertices. This can be a long, 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 long list. So what does this do? Well, if these are all xy points, like xy here, xy here, xy here, xy here, xy here, xy here, what I've now done is I've created a polygon that is a connected series of vertices. And I could do that algorithmically to make a kind of flower pattern. I've probably done this in a lot of other videos. But what's new here is what if I want the kitty, the image, to be, so I could say fill, right? And this whole thing would turn green. But what if I want to say, what if I want to texture the image into this shape? So I can do that by calling the function texture and passing it that image. The problem is, it's not really a problem, but the thing that you might not realize is in some level it's as simple as that, but it's not. Because you could say texture this shape, but it doesn't know which pixels to put where. So what you need to do for every single vertex is not just give the xy location of that vertex. You need to say this xy location also corresponds to some xy location in the image. So for example, if I wanted this section of the image to appear here, I would have to then say this xy on the screen, look up that xy in the image. And that's referred to typically as UV. So UV coordinates are lookup coordinates in an image that define the textured pixels. And this, by the way, could be XYZ. And I think when I do the thing that I'm going to do, I'm going to need XYZ. Oh, we'll see. Okay, X, Y, blah, blah, blah. Okay, so let's just make a quick example that does that. So where are we? So I am going to come here to a texturing example. I'm going to write a quick little bit of code. Okay, and I am going to, I've lost my train of thought here. I'm going to say size, 600, 400. I'm going to set a background. And then I want to say begin shape, end shape, and I'm going to say vertex 200, 200. Let's just make a bunch of vertices that are kind of arbitrary. I'm going to say vertex 300, 200. I'll just make it a square right now and say 300, 300. And I'm going to say 200, 300. So if I do this and I say stroke 255, fill 127, let's see what we get. Right? I get this shape. Right? Because that's exactly, I really just defined the vertices of a square. Now, one thing that's missing here is you notice it doesn't actually, you can't, it's hard for you to see this, but the outline does not on this part. So one little thing that you can see is I could say close. And close there will actually close the shape without me having to add that first vertex to the end again. So I could do some things like move these around, but let's actually leave them like this. So I think I have an idea for making this a somewhat interesting example. So now I need an image to texture. And here's the image that I'm going to use. This is Unikitty. It is a drawing drawn by an 8-year-old. It is beautiful. It is one of my favorite characters in the world right now. And let's use Unikitty to texture. Now, one thing I want to double check is Unikitty is kind of like a massively high resolution image right now, which is quite unnecessary. So I'm going to sample Unikitty down. And I'm going to do, how can I do this in? I'm going to say tools. Should have done this before I started this video. Adjust size. Let's just make it so we can kind of think about it, 600 by 600. So now what I want to do is I want to say texture. Oh, first I need to load the image. P-image unikitty. And then unikitty equals load image unikitty .jpg. And then now I'm going to say texture unikitty. And I'm going to run this. Now, we don't see. So first of all, we have an issue. Texture is not available with this renderer. So processing has different renderers that draw the scene for you. Your code stays the same, but the behind-the-scenes renderer does the drawing. And the default renderer is a software-based renderer built on top of Java's default renderer. But a hardware-accelerated renderer for 2D or 3D graphics that's built on top of OpenGL and something called Joggle, which is like Java Open Graphics, is called P2D. So I'm going to use P2D here. I could use P3D, but I'm not doing anything 3D here. So now, what happened? Where's my unikitty? Oops, okay. So we can see it's not there. It's because even though now I don't have any errors, I haven't defined those UV coordinates. So what I could do in the simplest sense is I could just assign the full image, right? Because top left of the image, right of the image, bottom corner of the image, bottom left corner of the image. So if I do that and now run it, boy, it takes a long time to start, or it's like on behind a, okay, that didn't work. Now maybe what I'm missing is, does texture have to go after begin shape? I didn't think so. There we go, I guess it does. So now you can see, there's unikitty. How wonderful. But this is no different than just drawing the image. But what's interesting about this is I could, trying to think, I could start to move these vertices around. So like, for example, if I just make, x equal, just the top left corner, x equals 200, y equals 200, and I do this, x, y, and then I say, x, x plus equals some random amount. This is like the least creative thing I could probably do with this. But just to show you that it's working, you can see now the image itself is going to skew to whatever the geometry is based on the pixels that I've picked. So you sort of get the idea. This doesn't have to be a square. I could make a polygon with 10 sides. I could assign them weird parts of the image that are different than sort of corresponding parts, and things will get stretched and skewed. There's a ton of possibilities here, but this is the basic idea. Now, in the chat, by the way, I see somebody asking, does processing not do UV coordinates in 0, 1? This is a great question. So a lot of programming environments will not take the raw pixel values, but just use what's called like a sort of normalized range. So the image width always goes between 0 and 1, no matter what the size of the image is. And I believe if I go to processing reference and I look up texture mode and go to that page, I can change image, normal. So this is, I think normal is what changes the range, between 0 and 1. So I'm just thinking in terms of the raw pixels, but I can use a different texture mode to do that. So that was a great question. Thank you for that in the chat. Okay, now, so that's basic. Now here's the thing. This is definitely in 2 parts, so I don't know. What I'm going to do, what I want to show you is one more thing. What's very common in a scenario like, where is this? Like this flag simulation, is that I don't actually want a texture. Now look at this. Are these, oh, these look like they're quads. Oh, I'm gonna have to change quite a bit. How did I actually do this? Oh yeah, so I've actually drawn this as, looking at this as lines. So I'm gonna have to redo the geometry of that. And here's a common kind, there's a lot, begin shape and end shape, right? I said begin shape and end shape, sets and vertices, you get a polygon, but there's a lot of kinds of things you can actually put in here that will generate shapes in a certain way. So I could say begin shape, end shape, and give it 3 points, and it'll give me a triangle. But I could also say begin shape, end shape, and pass it something called triangle underscore strip. What triangle strip is if I give it 2 rows of points, it'll actually make a whole set of tiled triangles. And this is a very common way of tiling geometry, I don't know what the actual right word is. There's a word for this specifically. And there's different triangulation algorithms that you can use to take any arbitrary geometry and get it to be a mesh of triangle strips. But I'm not going down that full road. So what I want to do is just show you, though, because my cloth simulation is a full big space with all of these interconnected particles, I want to tile it with a triangle strip and then texture the image, the Unikitty image onto it. So let's just do a couple things here to explain this a bit further. Number one is just to go to begin shape on the processing reference, just to see there are a bunch of things. Like this is what I just did, begin shape, end shape, close, but I could do the same thing but give it points, and it's just going to render those as points, or as lines, and it's going to give lines. I can use triangles. It's going to do triangles. This is a triangle strip. This is a triangle fan. These are quads, quad strip, and then you can see another arbitrary shape. So there's a lot of possibilities here, and this is what I'm going to focus on, triangle strip. So let's take a quick look at that. Where am I here? I need to go sketch, texturing. So let me come back to here. So what I want to do now is I want to show you how a triangle strip works. So I'm going to comment out the texturing. I guess I'm going to leave this in the code because when I publish this code, maybe I'll just make this one example, but I'm going to comment this whole part out and leave it at the bottom. So I'm going to start over. So now what I want to do is I want to say, let me have a row let me just have a row across. So I'm going to start with x. I'm going to use float. X equals, I'm going to start at 10. X is going to go all the way to 400. I'm just doing this arbitrarily. Let's do 100 to 500. I don't know what I'm doing. X plus equals 10. And then I'm going to say, let me also have a y. Actually, let me not have a y. So what I'm going to do now is I want to say, so one thing I could do, I'm going to say begin shape, end shape. And what I want to do is I want to say vertex x, comma, some y, which is going to be 200. Sorry, I'm trying to figure out what I'm doing here. So I'm showing you that I could write a for loop, and so you can see it, change the color to be white. Stroke, just make it a little bit thicker so you can see it as well. So this just gives me a line. Because what I've done is I've said begin shape, end shape, and I've set all these points across in a line. But notice if I were to say begin shape points, it's going to render it like this. All of those points. Those are quite close together. So let me make them further apart, and we can see it like this. Okay? Now what I want to do is I want to make a triangle strip. So I need to also have a set of points below. So I'm going to say x comma 200, and I'm going to say x comma 250. So now you can see these are all these points. And so I can point to it better. First one, second one, third one, fourth one, fifth one, sixth one. And that order is quite important. Okay? The order is quite important because I want to create a triangle and then another triangle. So it's going to do, so if I were to now just say get rid of the points, what you're going to see it's making is this. And it's weird because it's like connecting the end to the back and with a fill. So I'm also going to say no fill. And you can see here is now what I've actually done. I've got this zigzag pattern. And now the magic is, oh, I'm sorry, you can't see my code. I'm doing a terrible job of, the magic is I am going to add triangle strip here. And now once I do that, you can see, there we go. Now I have a triangle strip. So if I want to texture this triangle strip, all I'm going to do is, and let's use texture mode normal, just to sort of be interesting here. I'm going to say texture mode normal, texture Unikitty, and then let's just say I am going to, so the top is going to be 0 and the bottom is going to be 1 for that strip. I'm going to do the full height of the image in that strip. And then I need to say something like x. Well, I could say what's the, so I should use some math here. U is map x, which has a range between 0 and 500 to between 0 and 1. And then V, V I don't really need to calculate. It's just going to be, so I'm going to say this is U and this is V. So let's do that and see what we get. And what did I do? Oh, I didn't, 0 and 1. Sorry. Okay, lost my, now, text mode, what did I say? Text mode, texture mode. There is actually something called text mode, which changes the way text is rendered. And this should really be texture mode. So I made a mistake there. Okay, so then we can see, look at this. That whole image is kind of squished into this triangle strip. And it looks like it's just kind of behind this thing, but it's actually textured. And what's interesting, if I start moving all these vertices around, or think of them as polygons that separate, I could keep the same image geometry, but move the other geometry around and create all sorts of interesting effects. So this is where I want to stop. This is kind of just a texturing tutorial that I'm doing as part of taking this into a coding challenge. And so I'm going to, in another video that will be linked from this one, I'm going to do a coding challenge where I just apply the Unikitty texture to a flag. The Unikitty flag. I'll see you in that video, maybe. Okay, 8:12. How we doing, everybody? Oh my God, this is 2 hours. I think I've now streamed for 5 hours today in total, which is a little bit nuts. Oh my God. I am so happy about this pitcher of water. I cannot tell you. I'm going to purchase a water bottle so I can just fill it up. Because I couldn't find any water on this floor. I had to go all the way downstairs to a... Okay. Let's see. Okay. We are so close. We are so close to the weekend, everybody. You UK viewers must be asleep by now, right? Okay. All right, so now what do I want to do? I think what I'm going to do next is... Oh, no, it's not. I should never say is easy. Okay, so let me close that, and we're going to go here. Okay. Okay, here we are. No, there is I don't know why people are asking this. There's definitely several washrooms on the floor. But I don't want to go into the washroom and fill up the water. And also the sinks are those automatic sinks, so you have to like put your hand under there to get the water to turn on, and then it's kind of like warm water. So I want like a water fountain. That's what I want. In case you're wondering. Okay, Germany, Netherlands, Denmark. Why go to sleep? I go to sleep early. I like to, at least. I used to be such a night owl, but no longer. Not really quite possible when the little chickadees wake you up so early in the morning. Okay. Okay, so let's work on this. This is the last thing I'm gonna do today. And it's nice of you guys to say you're gonna stay awake till I finish. At tea finished. Okay. Here we go. I'm gonna see if I can do anything to keep these cameras alive. I can't. And here we go. I'm just gonna, I don't know if this really helps, gives me another half an hour, but okay. Here we go. Oh wait, sketch. So here we go. I think what I want actually is to, I'm gonna comment, I think it'll be better, let's comment this out and put this back in. I wonder if a triangle, will that actually work? Just curious. Oh, that's interesting how it does that. Okay, triangle fan. I'm just curious. Sorry, I'm like, UK figures are extremely tired. Yeah. Okay, so I'm just gonna do that. Okay. Okay, so now, hold on. Bear with me for a second. Trust me, nobody wants to be done with this more than I do, although I'm having a good time. Okay, so here we go. So I don't think that first video should be a coding challenge. It's not really a coding challenge. It's more of a tutorial. I'm going to think of how to do this now. Okay. This will all be archived and ready for you guys to watch another time. Okay, let's, look at this. Texture is out of whack here, but that's fine. Sorry. I can't have the texture being too crazy. So now I quickly have to have both these on the screen, and there we go. Okay, here we go. All right, welcome to a coding challenge. You might remember me from a previous coding challenge. I made that joke already in that other video. But that was a coding challenge. They are coding. It's in 2 parts. It's a coding challenge in 2 parts. This is the second part. So what I'm going to do in the second part is take the knowledge from the first part where I looked at how to texture geometry with an image and apply that to this idea of a cloth simulation to try to make a waving flag with an image on it with our new friend, the Unikitty. So you can see this is kind of happening here. There's this crazy image that's being textured to this geometry. And if you didn't watch that video and don't know about how the texture function works, I would encourage you to go back and look at that first. But we're just going to get started right here. So this, this is kind of a rare thing that I'm doing here where I'm not starting from scratch, but I'm actually also building off code that I built from scratch in a previous coding challenge. So you can also go back and watch that one. It was coding challenge number 20, 3D cloth. But here's what I'm going to do. So let's save that. And now I'm ready. Okay, so let's look at this. The first thing that I want to do is I want to make this more like looking like a flag. So even before I add the texture, let's make it look like a flag. So a couple things I'm going to do. Number one is, this is where I lock the particles. So I lock the particles 2 on the top. So if I remember right, I could say lock 1 on the top and 1 on the bottom. And you can see, oh, that is weird. That is weird. So another thing I want to do is get rid of this rotating right now, because it's making it confusing for me to see what's going on. So let's run this again and see. Oh, okay, wait. Oh, but there's all this. Okay, let's do something else. Let's get rid of the gravity for a second. Let's take out this gravity behavior, because that's kind of confusing me what's going on. Okay, so that's, so the orientation is also completely different. I forgot about that. I oriented the cloth as this thing up. So what I actually need to do, what I probably could do is just change the way the scene is rotated. Let's see, how did I do that? So if I rotate the whole scene, if it's up here on the x-axis, it will be rotate around the x-axis, right? By 90 degrees. Will that work? There we go. Okay, so there it is. I could have just changed the way I created it, but let's just keep it. I'm going to rotate the whole scene that way. And then what I want to do is, now I've confused myself. So where is the gravity pointing? Is the gravity, which axis is pointing down? And maybe I should reorient the way I do the particles. Let's reorient the way I do the particles, because this is going to be way too hard to figure out if I rotate the scene, right? So this is a better idea. Look at this. I set all the particles with a fixed y, and x and z are what are changing, which is why x moves across this way, or x moves across this way, and z moves across this way. Now I want z to be fixed, and x and y to move. So all I need to do, I think, is just change this to y, and set all the particle locations to y, and have z be some, I don't know, just make it 0. So I have a feeling that there's going to be a bit of a problem here, where it's going to be in the wrong place. It's at the bottom. That's no big deal. I could say y should start at rows, negative rows times w divided by 2, so that it starts higher up. And you can see, there we go. Now what I want to do, I also want to give myself some more space here, because I'm going to have this nice flag waving simulation. So I think I'm going to just give myself 800, and I think x should actually start at, I don't know, I'm just going to sort of hard code some stuff in here to like shift it over a little bit. And that's too much. Shift it over like this. Okay, so now, there we go. The other thing I'm going to do, this is kind of silly, but I might as well, is I'm going to, at the end, I'm just going to draw a line. Stroke 255, stroke weight 4, and I'm going to draw a line from, where's the first particle? The first particle starts at this location, comma this location, oh boy. line from here. I should do a better job of thinking about how to organize these as variables, but I just want to quickly put something to make it look like the flag's attached. And I'm going to go from that point all the way to this same x, and then down to the bottom of the screen. There we go. So this is a flag, but it's not waving or doing anything. And I might need to set it back on the z-axis or something, depending on how things go. But now I can put that gravity back in. So gravity points down. And let's look at it again. Oop. I need to add the gravity behavior, not just look at it and run it again. There we go. Oh my goodness, look at that flag. It's just falling down. There's nothing going on. So one thing that I want to do is push, add some wind. So I want to add some wind, and I could probably take out the gravity just in terms of like finessing it here, but I want to push it in that other direction. So the particles, are the particles all in an array? The particles are in a 2D array, and I'm doing all this stuff with them here, and then so there's a lot of things I got to change, but one thing that I can do, this is all just setting it up, sorry. Perfect. This is where I want. This is a loop that draws all the particles probably as dots or something. So let's take out s.display. So what I want to see is just the particles. Oh, you can't see them. So what is the particle display function? Oh, it's taken out. So I don't know why that was commented out. So let's put that back in. So these are just the particles. And boy, they fell quite far away. What happened there? Are they, hold on a sec. Let me do this. And let me say, everywhere I draw something, I need to let me make this stroke weight 1. And let me make this no stroke. And I think what I need to do to see this also, oh, look at that. The particles are, why are they in the wrong place? Particle equals x, y, 0. Physics add particle. Why are they? I mean, I don't really need to. I'm just curious. Like, what's wrong? Oh, these should be at 0, 0, right? If I'm I don't know. I had that coded from before. It was a mistake. So if I'm translating to x, y, z, the particle should be drawn at 0, 0. Okay, there we go. There we go. Okay, so this looks like what I expected it to. Now I can see, and what I was going to do, I think it'll be easier to look at what's going on also if I really, really increase the resolution of this. So I'm going to make the number of columns and rows. I should have these calculate based on each other, but I'm just going to make it much. So you can see now this mesh is a less high resolution. So we can sort of see there it is. So now what I want to do, what I wanted to do here, and I don't need to display them, is I want to apply a force to them. So I'm using the ToxicLib's physics engine, and it has a function called apply, it's add force. Yeah, there it is, add force. So this is a function that allows me to arbitrarily add a force to it. And I'm going to add a force like, and that force should be a vector. So I'm going to call it wind. And I'm going to say vec2d wind equals a new vec2d, and it points 5, 0. And, it needs to be 3D. I forget that I'm in 3D world. So 5, 0, 0. So now we can see the wind is sort of keeping it more like a flag. Now here's the thing. It's working, it kind of looks like a flag, but it would be much nicer if that wind were kind of inconsistent, and also if maybe there was some wind along the z-axis as well. And I always just use Perlin noise in these types of situations. So what I'm going to do, I'm not even close to the texturing yet. Well, I'm close to the texturing. So let's try to make the wind a bit more interesting. One thing that I can do, I've got this two-dimensional space, which is really perfect here. So I can consider an x offset for Perlin noise and a y offset for Perlin noise. And I can say the noise value is noise x offset, y offset. And for every column, x off should increment by something. And for every row, y off should increment by something. And then, actually this should probably be at the bottom, not that it really matters. And then what I could do is I could say this is n times 5, and this is n minus 0.5. So those should probably be different. Should use different values for. Okay, let's be better about this. Let's say, because I want to make this look nice. Let's say wind x is noise of x off, y off, and wind z is noise of x off, y off. And what I'm going to do is I'm just going to like offset these by, I'm going to just like look at a different part of the noise space that's like arbitrarily some other number so that I get different values for wind x and wind x. For wind x and wind z. And then what I need to do is map those. You know, this is a little bit silly to use a map here because the range of noise is between 0 and 1, and maybe I want to always have some wind, so between 1 and 5, always pointing in that direction. And then I want to map z, though, which has a range between 0 and 1 to between like -1 and 1, because the wind could push in and out. And so now if I do that, let's see what we get. We're getting kind of more like the wind is kind of changing over time. But here's the thing. It's kind of settling in. I can do even better. Because even though the wind is different in a sort of smoothed way across all of the points, it's not every frame. So I can add a third. Boy, this is like a lot of Perlin noise stuff for all this texturing stuff that I didn't realize I had. I can add a third dimension, which is really the frames of animation, the time. Perlin noise. So z is really, the x and y is the noise in the 2D space of the flag, and z is every cycle of animation. So what I'm going to do now is I'm actually going to look at z off, and I think I could just use the same z off for each. I don't think that'll matter. And then globally, every frame, z off will change by some amount. So now I believe that I'm going to have something that feels a bit more like wind that's changing over time, and it's not really going to settle in as much. I'm sure I could play with the parameters and the amounts, but you can see we've got our flag. And I think I think the gravity should maybe be not so strong. So I'm going to just make the gravity a little bit weaker, and I'm going to go back now to having it be many, many more points, which I also think will be more interesting to look at. Whoa, okay, so I think I've made the wind a bit too strong. It's like really stretching it out. This is the kind of thing that really some finesse and some playing around. I'm gonna let you, if you download this code, like play with the parameters a bit more. But I can make the wind a little bit less strong. Also the strength of the springs is probably a big factor here. So if I go into the springs, they all get made. Where do I make the springs? They all get made with a strength of 0.8. So if I made it like a 0.1, I think it's going to make it really crazy flimsy. Look at that look at that insanity. And I could probably strengthen it up a bit by making the strength 1, which might give it a little bit more. So who knows whether this is better or worse. But now we're ready, right? Now we're ready to do the texturing. This was the point of this video in the first place. So where's the geometry that I can texture? So what's actually being drawn here? If I look inside draw, you can see this is actually where the flag is being drawn. Every spring is a connection between 2 points. And s.display, what does that do? It draws a line between those 2 points. So now what I need to do is, I don't want to do this anymore. That's not going to work for me. What I need to do, and I think I want to do this in another loop, because this loop is crazy, but I need a loop of columns and rows. I need to render this with the particles. So I need to go back to particle.display. Particles index I, index j dot display. So let's just make sure this works. So now I'm rendering it as a lot of points. And I just want to make that easier to see by making those points smaller. And you can see that now. So this is really what it is. It's a whole lot of points. Remember that triangle strip thing? All I need to do is fill it with triangle strips now, from top to bottom. Okay? Could you add 1 or 2 more locked points? I definitely could. So maybe that's a good suggestion. Maybe I'll do that. I kind of have some momentum here, so maybe I'll add that a little bit later. But that's not a bad idea, to lock a few more points to the pole. And it wouldn't be too hard to do that. It would just be a matter of picking some other points to add right here. Okay, so what I need to do now, though, is I need the x and I need the y. And what I'm going to do is I'm going to turn off the physics just for a second. So what's the easiest way for me to do that? Just comment out physics.update. So if I comment out physics.update, oh, but I don't, oh, because there should be no physics, but I forgot to display anything. So I just want to make sure this still works. So there it is, but no physics. There's the flag. Okay. So now I wonder if my rest length is off too. That's something to think about. But so now what I'm going to do is I'm going to say begin shape and end shape. And I'm going to say begin shape points. And I'm going to say vertex, and oh my goodness, I cannot believe that I forgot. I really need the z here. I'm going to say vertex x, y, z. Let's see what we get. So now I should get, there's my geometry. It's just a set of points. Okay, we're in good shape. Okay, so now I don't want points. What I want are triangle strips. So triangle strip. So this is going to be wildly off, but let's run this through. What happened? Oh my goodness, I can't even make any sense of this whatsoever. Let's make sure there's no fill. Let's make sure the stroke weight is just 1. And let's lower the resolution again. Boy, this is driving me crazy. I want to have a variable. So I'm going to call this variable resolution, and I'm going to call it, I'm going to say it's 1. And then I'm going to say 40 divided by resolution. 40 divided by resolution. We can make this a float, I guess. And then I'm going to say width is w times resolution. So this way, oh no, this needs to be an int. Okay. This way, this should be exactly what I had before. And then it's hard to see. And then if I change this to 2, I should be able to see it even better. If I change this to 4, we can see, okay, so this is not right, obviously. It's drawing some crazy mutant triangle strip thing that's not right. So what's the issue here? The main thing that I think will make this a lot easier to deal with is that right now that loop, the columns is on the outer loop. So it's actually saying for every column, go through all the rows. I could have the triangle strips going down, but to me, for whatever reason, I'm mentally thinking of it going across. So I actually want to have the columns in the inner loop. So I say for every row, go do all the columns, but do the column and then really for every y, do all the x's. And do the x, do x and y plus the next one. So in other words, what I'm saying is, I don't know if that was clear, but I want this to be in here just the way I'm thinking about it. And then what I want to say is, give me 2 different y's. Like give me y1. Actually, I need all of them. I need x1, y1, and z1. And then I need the one that's right below it, right? Because the triangle strip is going to connect to the row that's below. So I need to say then x2, y2, z2. And what is the one below? J plus 1, j plus 1, j plus 1. So then I can have another vertex. 2, 2, 2. Okay? So I have 2 vertices. And now let's take a look at what this does. Oops. Array index out of bounds. Oh, of course. So what's the problem here? I can't do the last row anymore because every row I'm looking at 2. So I have to say j is less than rows minus 1. That'll get rid of that error. And you can see, okay, so this kind of looks right, but there's all this stuff like connecting back to the beginning. So the thing is, the triangle strips, each row has to be a distinct unit. So even though I said begin shape and end shape for the whole thing, and when I get to the end over here, it has to connect all the way back to the beginning. Now I could try to do something clever where it kind of wraps around, but what's going to make it much simpler is I can just say, let's actually begin the triangle strip for every row and end the triangle strip for every row. And now you can see that I now have this whole flag as triangle strips. Boy, we're really close now. And I can go back and I can change the resolution to 2, and we can see still the same thing. This whole flag as triangle strips. So now what do I do? Here's the good part. Now what I do is I need to load the image. So it's time to say pimage unikitty Then I'm going to say, I don't know why I'm looking at the bottom. Unikitty equals load image, unikitty.jpg. And that file just has to be in the data folder for the processing sketch, which you can see that it is right there. And now I can say, right here, texture unikitty. And all I need now are the UV coordinates. So what are the UV coordinates? Well, U is a value, X, what is it? I and J. I goes between 0 and columns, and the image pixels go between 0 and unikitty.width. Now I could use normalized texture coordinates so that this just goes between 0 and 1. That probably makes things easier. It's kind of nice to do that. Maybe I should do that. What do you think? I'll do that. I'm going to say texture mode, was it normal? This way I can just do this. I don't really need map even. I could just take I and divide it by, so this actually makes things simpler because I can take I and divide it by columns. Whatever, I'm going to keep map, which has a range between 0 and columns, now to map that between 0 and 1. And V, which has J, which will range between 0 and rows, to have also between 0 and 1. So now, UV. And then the next vertex, all I need to do is redo J and ask for J plus 1, right? Because I need the V. U can be the same, right? It's the same X values, but I'm looking for the pixels in the row below. So V has to be J plus 1 and V here. Oh my goodness, I'm in front of my code. So I think this should work. Rows minus 1. This is a good point. It really should be columns minus 1 and rows minus 1. I think that's right. Rows minus 1, because the range is actually, if there's 10 columns, the range is between 0 and 9. I think that's right. So I'm going to say V1, I'm going to say V2, V1, and V2. So now, if we run this, we should see Unikitty on the flag. There we go. This is so exciting. Unikitty is on the flag. Now what we can do is put the physics back on. I need a Unikitty song to play. And now we have the Unikitty flag. There is the Unikitty flag. Oh, all of a sudden it's not stretching out so much. What did I do? It seems less crazy than it was before. And by the way, now I really want to just take off this. This would be a little bit nicer if I had a non-square image that I could make a little bit wider also, and then the columns and rows wouldn't have to be equal, because a square flag is a little bit strange. But I'm going to say no stroke. I would really like to maybe increase its wind or whatever, but I think I'm done. So here we go. You can make your own creative version of this. It's the Unikitty flag. I took a beautiful drawing of a Unikitty. I have textured it onto some geometry in processing. I have added some physics with the Toxic Libs library, and it is the Unikitty flag. Thank you very much, and I will see you. Good night. That's my last coding challenge ever. I feel like, what else could you possibly ever want to make after this? I'm sure I'll be back. I'm very tired right now. You're watching this in the future where it's just like one video, but I've been live streaming today. I'm in my hour number 5 here. So see you later in the next video sometime. Have a good day, evening, morning, whatever time it is for you. Go give somebody a hug. Draw a Unikitty. Talk to you later. All right, strengthen the springs, increase the wind. I would love all of you to do all those things. Thank you very much and good night. I feel like this also merits some dancing with the Unikitty flag. What's weird is like the shuffling feet sound effects probably that you can hear this picking up from the microphone. Okay, I'm gonna play my goodbye song. I don't know how loud that is. I am potentially happy to take 1 or 2 questions from the chat. And UK flag would be nice. But I'll let people pick their own countries. Good screensaver, yeah. The Unikitty really works well on that flag, I have to say. All right, actually, I can't believe I'm watching this. Yeah. Good night, Brazil. Can I explain AVL trees? I don't even know what those are. I guess I'll Google it later. Add more locked points. I think the flag actually looks quite nice. So flags are just tied in 2 positions, right? Wouldn't it be weird to have more locked points? Go ahead and Alka and add. I'll upload the code. You can add some more locked points and show everybody in the Slack channel. I can't bring myself to do it. Even though you did a sad cat crying emoji, that was pretty great. It's 2:41 a.m. and I'm watching a grown man dance to a lullaby. I would take issue with the grown man part of that sentence. It was a lullaby and I was dancing, but I don't know how much growth I have. Good night, Philippines. Did I do inverse kinematic constraints in this session? I don't know if I did exactly restore the full resolution. Oh, did I not restore the full resolution? No wonder. Thank you for that reminder. There we go. There's the full resolution. Rotate the flag. Please add the Unikitty picture to the download link as well. Oh, it will be. It seems to be running kind of slow. I don't know if that's other stuff going on the computer, but video on the flag is a great idea. Good night, Slovakia. First band should have stronger springs. That is a great suggestion from TMC in the chat. Great suggestion to actually change the strength of the springs based on where it is. Yeah. Good morning from Korea. Wow, that's amazing. People are waking up as I am finishing. I don't know if this is what you should wake up to. Rotate around the flag, please. Okay. Since I have that in the code already, I really should add Peasy Cam is what I would recommend, but this should give some rotation. I think maybe I should add a little bit more Z wind to it. It's kind of nice to see because yeah. But Peasy Cam would be nice. It's a processing library that allows you to control the view of the camera. Put a video on the flag is a great suggestion. Would love to see somebody do that. Please put a beard on the cat. I don't know if the Unikitty should have a beard. Oh, song's over. Okay. Thank you, everyone. This is definitely, I think, a record. Just to answer one question, because it was about Google Summer of Code, is processing or P5 taking students? Processing and P5 are different projects, but they're both part of the Processing Foundation. So the Processing Foundation is an organization for Google Summer of Code. So if you want to work on one of those, you apply to the Processing Foundation and specify which one. And India just woke up. Okay. Okay, can you have a link to the this dot song? I'm sure somebody could give it to you. It's on SoundCloud. I know that only a few people are able to post links into the chat because it's, sometimes I add somebody and give them that capability. But Alka, maybe you could do that since I see that you're in the chat right now. Okay, thanks everybody. I'm going to click the stop button. I'm going to stop recording. I'm going to click the stop streaming button, and I will see you all next Friday is when I'll be back. For another live stream, and who knows what will happen. I have no idea. Oh my God, I think I might do some machine learning stuff next Friday. I'm terrified. Please help me. Send me some examples. Send me some tips. Okay, goodbye.